This lesson is our last video instruction of the semester. Can you believe it? We are almost done. In this video, we're going to talk about writing out our objects to a file and reading it back in, and that should give you everything that you're going to need to know for the final project. And without any further ado, I guess let's get underway. So I've got this simple little data model. It's very trivial, but it demonstrates the principles that we need to understand for our assignment. I've got a base class. It's called value, and it's got 4 subclasses: a string value, a Boolean value, an integer value, and a double value. And as you can see, what's different between the 4 child classes is the data type that the value property has. One's a string, one's a Boolean, int, and double. Everything else is basically the same. The toString method is polymorphic, so it's going to provide a different value based on what gets printed out. So you'll see here the value class is the name. It has a private name field, and then it's got protected constructors. And as we've talked about in our discussion boards, you would make a constructor protected if you don't want the application code to be able to create one of these things directly. I could also make it abstract, and oftentimes we do both, as you've seen in our menu example from last week. But in this case, there's nothing really abstract about the value class, and so I just protect the constructors so that my application code cannot create a value directly. It has to create a value by creating one of the subclasses. So let's take a look at our value base class here. I've omitted the comments so that we can fit more on the screen without having to scroll up and down, and it'll also make it, when I post the code to the discussion board, it'll make it a little bit easier to read. But generally, we would want to have good comments on code. This is all very boilerplate stuff. They're all pretty much the same. And so line that indentation up there, but I've left the comments out. So our value, you'll see here, it's got the name field, it's got protected constructors, one that's a default constructor, one that takes the name as the constructor. You'll see why, finally, at the end of the semester, why we've always recommended to have a empty default constructor with getters and setters. It just makes loading these things from a file a lot easier. And getters and setters for the name and the toString method. And then we'll just take a look at one of the subclasses before we get rolling here. Our string, all of the other subclasses are identical, with the only difference being the data type of the value field. And even though they all have, if we come back here really quick, even though they all have a value field, it's not the same value field. It's not really polymorphic in this case, because of the return type and the input type on the setter. They're not overloads of each other, and they're not overrides of anything in the parent class. So it's not really polymorphic. We just happen to give them the same name. But the toString is definitely polymorphic. So our string, you'll see here, we've got our string value, a getter and setter, default constructor, and a parameterized constructor. And then our toString method is actually different. And this is what will be different: the data type here, the data type in the getters and setters, and the data types involved in the toString. Okay, so we're going to have a demo program that is going to create an array list of our value objects, and we're going to add 4 different value objects to it, one of each specific child type. So I'm going to create a string value, print out value 1, Boolean value, value 2, etc., and I'm going to give it appropriate values for the types that they are. I'm going to print them out using this little method down here. It's just a little helper method. I wrote it as a separate method because there's 2 places in my program where I want to print my values, and I only wanted to code the print logic once. So I put it in a separate method to make it easier to maintain. So we create our array list of values. We print them out to prove that everything works. And you'll notice as we come down into this print values, I take advantage of the polymorphic toString method, because I know that every value object is going to have a toString method because it inherits from value, which itself inherits, all objects in Java ultimately inherit from the default object class, and that defines a println method. So I know that all objects will have a toString method, not a println, a toString method. So I can call the toString method on anything, any object that I get out of this list, and it'll do its thing. It might be an ugly string like we've seen, or it might be something interesting that we've coded ourselves like we've done in our own toString method. So after I print it out, I'm going to write my values to a file, and then I'm going to turn around and I'm going to read my values back in from the file, print them out again so you can show yourself that we have loaded the values back in appropriately, and then the demo program is done in this case. So let's run this program and see what it does. So if I hit run here, so here we are. We'll see we printed out our value number 1 with its value. Value number 2 was a Boolean, we printed out true. Value number 3 was an int, printed 2020, and a value double, we've printed 95.5. So in our reloaded values here, you'll see that I got nothing to print, and that's because I have logic down here that says if what comes out of that load values or load data from our storage class, which we'll see in just a minute, if I got nothing or an empty list, then I'm just going to print that out and bail out of my print method. So the reason why load data did not load any data is because our storage class is actually empty. And that's what we're going to demonstrate for the rest of the video, is writing these two methods, one to write the data out and the other to read it back in. So why don't we get started doing this? We'll see here that I have this storage class, and it's just a class full of helper methods, so they're static. I don't actually have to instantiate a storage object. I can just, in my demo, I can just say storage.loadData or storage.storeData. So my store data is going to, we need to pass in the file name to know where to store the data, and then the actual data itself, so which is our array list of values. So the thing is, with writing stuff out to files, there are infinite ways, literally infinite ways that you can choose to store this data in a file on your hard drive. And we're going to choose a very simple text file format with a simple delimiter that will allow us to figure out where each field starts and ends in our data. And so our format is actually going to be a 1 line per record. So we're going to say text format. This is just me making some notes. Text format, 1 line per object. We'll call it an object. And it will be delimited by a vertical bar character. That's, the shift vertical bar at the right end of your keyboard. And the reason I chose that character is it's highly unlikely that that character would show up in the user's input. If for some reason it does, we might have to be a little more tricky in how we encode this, and you've seen that by having a backslash in front of something. We could choose to do that. We could choose anything we actually want to do. And in our case, I'm going to keep it very simple. I'm going to use the vertical bar as the separator, and you'll see why in just a minute. It makes it really easy to read. A very common format is a comma-separated value format, where the different values are separated by commas instead of vertical bars. And so very common text format. We could write these out as binary, but then you wouldn't be able to read it and verify, look it over, make sure that it worked. And unless you have a specific reason for writing binary data, we just don't do it anymore because it doesn't translate well across computer architectures. So here we go. Let's see what we got to do. First, we need to create a output stream for it. And I like using the print writer for it because it gives me a print line method, so I can use it just like I've been using my standard, my system.out. In fact, system.out is actually a print stream. And so that's why it has a print line method. So I'm going to use something very similar. And the way we're going to do this, and I'm shooting from the hip, I could pull up documentation, but I'm too proud to do that, I guess. We'll see if we can do this from memory and have my IDE help me out. So we're going to say var writer equals new print writer, and look at that. So PrintWriter has a constructor that takes a file name. Yeah, I think I'm going to go with that. So our file name is going to be our file name. That's pretty cool. Now we are going to need to import PrintWriter. So I'll hit the quick fix. I'm using Visual Studio Code today because I wanted to be able to show you our UML diagram in the editor. This was actually created from this model.plantUML. It's using a plant UML file that or plant UML tool that I like to use, plantuml.com if you want to go check it out. Anyway, so we're in VS Code. Sorry about the tangent. So now I've got my writer, and you'll notice that my method throws IO exception. And that means that whoever calls this method has to handle the fact that I could potentially throw an exception for whatever reason. And so here I'm going to, now I've got my PrintWriter, I'm going to loop through my value. So I'm going to say I'm going to do a for each loop because I'm just going to go walk through one by one. I'm going to say for var value in data. And let's get proper white space there because that's important. And then we're going to say, now we got to write it out, right? So how are we going to distinguish between the different types of child classes that we have? So it looks like we're going to need some kind of logic to be able to say, if this is a Boolean, then we're going to write a Boolean value out. And the reason why we want to know which type it is because when we get down to the load data down here, we have to, when we read that line of text, we have no idea whether that line of text came from a string child or a double child or an int or a Boolean. And so we kind of need to give ourselves a little hint. And so that's why we want to write it out with a little hint. So in this case, I'm going to say if, and then I will say if value is instance of, and then I can say string value, then I'm going to do this logic. And then I can say else if value instance of Boolean value. And then I'm going to say else if value instance of, and I think next is int value. And then finally, else if value instance of double value. I don't really need a final else. These are all the values that it could possibly be because we know, because we're writing the software ourselves. These are showing errors because we need to import them. The reason we need to import them is because I've actually defined my values in a separate package. Make sure we import from the right package, which is my values package. In Java, packages equate to the directory structure that your project has. And so in this case, you can see here I have a values directory. So my demo is implemented in the root of my project, but I have a values subdirectory, and that equates to a package. And so if we look here, you'll see I've got the package statement at the top of my file. And that lets the Java compiler know that this file belongs in a packages, or in a values package. And then when I come back to storage and I say import values.boolean value, it's going to go to the root of my project and say, I'm expecting to see a values directory. There it is. And inside of there, I'm expecting to see a Boolean value class, and there it is. So that's what the separate package is. And you might try separately packaging different parts of your project code. It just helps to modularize it a little bit better. In this case, I said the values are all kind of one little library of things, and I'm going to store them all in their own thing. And that just lets me keep my project clean by collapsing the directory structure if I don't need all that clutter. All right, so now depending on the different types of values, I'm going to write something a little bit different to my file. You might be tempted to just use your toString method and write that out, but if your toString method is fancy, like ours is, if we come back here, our toString method is pretty fancy. And it's going to actually make it harder to read that line of text, because then I'm going to have to parse and say, well, what is there a name colon in front of everything? And if there is, then the next part up to the comma is the name, and then if there's a value colon, then everything after that is the end of the string. But then if there's something in parentheses, I skip that. Or this could be my hint, but I'd have to know it's in parentheses. Just a lot more. There's a lot more structure on this line if I want to try to parse this, and I want to keep this really, really simple. And so what we're going to do is we're just going to write out, since I know we've got a string value here, I'm going to do a writer.println. And so this is going to be the format of my file. I'm going to write out the word string, and then I'm going to put my first delimiter. So string is the first thing on the line. And then the next thing is going to be the name. So I'm going to say %s. That's going to be the name that the parent class has. And then finally, I'm going to say %s is my value. And then I did my print line. So actually what I need to do is, instead of print line, I need a format or a printf. And then I'll have my carriage return line feed at the end. And now I need to get my, I'm going to say value dot get name and value dot get value. And there's not a get value, it's a get string value. Oh, duh. Value, this value object is actually since we've told it it's a value type, it doesn't know that it's actually a string value until we get to this point. So right here, I can say, and I'll just do this for simplicity, I'll say var string value equals string value value. And then I can say string value dot get name and string value dot get value. All right, now what's writer complaining about? Oh, I haven't closed it yet. Oh, and actually what I really want to do is I want to do this. I want to say try and I don't need to catch anything because I want the IO exception just to flow up. So I'm not going to catch the IO exception. I'm going to let it bubble up because our method will throw it out anyway. Throw it up, not out. Okay. And so the next thing we're going to do, so that takes care of the string, but if we're not a string, if we're a Boolean, then we're going to say var bool value equals, we're doing a typecast. We're telling the value variable, we're telling the compiler to interpret the value variable as a Boolean value. That way we know that we can call the get value method on it that it has, because our parent class doesn't actually have a get value method, but our string value did because we defined it. And all of our other child classes also have one. But as I said, those aren't polymorphic. We just happen to use the same name. So then I'll do a writer dot format, and this one I'm going to say Boolean and give it my delimiter, and then a %s for the name, and then a %b for the Boolean value, and a new line. Then we just say bool value dot get name and not string value, bool value dot get value. And we're writing this stuff out little by little. Text files are wonderful formats. It used to be in the old days, text was looked down upon because you could fit a lot more data in a binary file. But nowadays, memory is cheap, and so we tend to waste memory quite easily. And that's what we're going to do today. This little file is going to take up virtually no space on your hard drive. But it does take some. So next up, we're going to say our int value. So we're going to say var int value equals, cast it to an int value child class. And then we'll say writer.format int %s and then %d, new line, and we say int value dot get name, and I keep looking at the line above, int value dot get value. And then finally, var double value equals double value value, and writer dot format. We're gonna output double, and then a %s, and then a %f. And I'm not formatting this in any way. I don't want to lose any of my data. So if my data happens to have more than whatever format of the decimal digits, I don't really want to lose that. So I'm still going to write out the full value that Java has for it, whatever it is. So then we'll say double value dot get name and double value dot get value. And there we have it. We will have now written our whole file, our whole list of data out to a file, one record at a time. I'm going to show you one little trick that I like to do for text files that might make things a little bit easier on you when you're just looking at them. And it'll cause us to have to skip over these lines when we go to read the file in, but I think it's good practice. You're welcome to do it. You're welcome not to do it. But I'll just show you what I often do is I will include a comment line that explains the file format. So here we're going to say, whoops, let's do this right up here. After we've opened it, we'll say writer.println, and I need some kind of a comment delimiter at the top. Why don't we just use our Java single line comment token there, and we'll say file format, and it will be the data type, vertical bar, the name, vertical bar, and the value. Like that. So now when I go to read the file in, I'll just have to look for a line that starts with a comment character and skip over it. That way it won't mess up reading my data. So now that we've got this, why don't we run our demo program and see what we get when we write the values out. So come up here, we're going to run our program. So we have now written our values out. This is what they look like when we print them to the screen, and this is what they look like when we look at them in the file. You'll see here, there's my comment line that I just added. Now there's my data type, my vertical bar, the name, another vertical bar, and the value. And that's our file format. So that's pretty simple. So let's go back now and implement storage. On the other side, let's load our data back in. This is going to have to be a little bit more tricky, but it's not all that much more tricky. And so we're going to use our good old friend scanner. There are lots of ways we can actually read this file. There's methods in newer versions of Java that in the NIO package or the new IO package where you can say, hey, given a file, just read all the lines and put them into an array of strings. And that's actually pretty simple. It's probably how I would do it, but I'm going to walk you through the scanner because you're already familiar with the scanner. So here we go. We're going to say try. And then I don't believe the scanner actually throws IO exceptions. We're going to find out here pretty quickly though. So we're going to say try bar input equals new scanner. Now we have to be really careful, as we saw a couple of weeks ago as I fumbled in one of these videos, that the scanner, you can't give it a string as the file name. You have to actually give it a file object. And so I'm going to say new file name. So let's import scanner and import file. And up here we say, oh yeah, we're going to have a array list here of our values. So we're going to say var data equals new array list of value. and then we're going to return it. Whatever we've loaded, whether it's empty or it's got data in it, we're going to return it. And so here we go. Now, our output is line oriented. And so I'm going to read this in line by line. So I just have to use the scanner next line method. So I'm going to say, for as long as our input that has next line, I'm going to read. I'm going to say var line equals input.next line. So now I've got a line of text as a variable in my data. So technically this first line, I'm going to have this line. So the next thing I want to do is just double check. If I've gone to the trouble, you don't have to do this, but if I've gone to the trouble to add an explanation line, like if you have a CSV file, you might have a title, a row of titles first. I need to check for this and then just skip over it. So I'm going to say right here, I'm going to say if line.trim.starts with my comment character, then I'm just going to continue my loop. I'm going to skip the rest of my loop and go back and read the next line. And so now what I need to do, because I wrote things out in a delimited way where I've got the vertical bar, I need to actually split this line based on that vertical bar. And what that's going to do is there's a split method on the string class, and that will return an array of the different strings. So if I say split on the vertical bar, then it's going to return me an array of 3 items. The first one will be the data type, the second one will be the name, and the third one will be the value. So I'm going to come back here and I'm going to say, we're going to call this fields, and it's going to be line.trim.split, and this split method takes a regular expression. And so if you use the vertical bar, vertical bar has a special meaning in regular expressions, so we need to escape it to make sure that it's treated like text. And so that's what this double backslash does. If you're like me and you choose this vertical bar as your separator, then you'll probably need to just add this double backslash into it. If you've chosen a comma, then you could just have the comma be the splitter. But I chose a vertical bar. So lucky us, right? So now I've got this array of fields here, and my next thing, just like I went through and I said, if my value is a string value, then do this. Now I'm going to say if the first field or field sub 0 is the word string, then I'm going to create a string object and populate its values. If it's anything else, and we know what we wrote out here, and it's often beneficial to do your writing code first, so you know what to read in when you go to write the reading code. So then we just say if field sub 0 dot equals string, then we're going to do some string code. We're going to say var, spell it out, string value equals new string value, and I use the default value because I don't have the name just yet. And then next I'll say string value dot set name, and we know that from our output format, the name is the second field, so that would be fields sub 1. There we go. And then we know that from our format that the value is fields sub 2, or the third one. And because we're dealing with a string on this case, then we just get to put it right in there. We don't have to convert the data type. So now we'll simply say string value dot set value, and we'll say fields sub 2. Very cool. Now, one thing we're not doing is we're not really handling the case where somebody might have hand edited our file and just being mean, got rid of this. You know, if they got rid of that field, that would throw our parser off. So we might want to have some checks like this that would say, if fields.length is not equal to 3, then we will say, we're going to say throw new IO exception, invalid file format on line number. Where's that line number coming from? I haven't created it yet. We're going to do it right up here. We're going to say int line number equals 0. But as soon as we read a line, then we're going to say line number plus equals 1. That just helps us write out this error message. Remember, this is not necessarily, exception messages are not necessarily intended for user consumption to be shown to the user. It's really a note from one programmer to another. In our case, in our demo, we're going to end up, we print out the exception. This is just a demo program. So just a reminder of good, proper exception etiquette. All right, so next up, we need to add this to our list. So we're going to say data.add string value. All right, so now let's double check what else has to happen. Well, we've got 4 other data types. So we've got Boolean, int, and double. So let's take care of these as fast as we can here. So else if field sub 0 dot equals, and the next thing is Boolean, and we're going to do var bool value equals new Boolean value, and we're going to say bool value dot set name, and we're going to say fields sub 1, and bool value dot set value, but this with our field sub 2 is a string, and we need to convert it into a Boolean. So we're actually going to use the Boolean class, Boolean dot parse Boolean, and give it fields sub 2. So that's going to read true or false and turn it into a Boolean value. And then we're going to say, we're going to say data.add bool value. Very cool. Now, this parse Boolean could, if somebody goes in and edits our file and changes this to true dude, well, that's not actually a Boolean value. And so that's going to throw an error. That's going to cause a number format exception. And so we just want to, let's double check and see what parse Boolean actually could potentially throw. Let's see, parses the string as a Boolean. It's true. Oh, look, this doesn't actually throw any exceptions. That's cool. So we don't have to add our try catch until we do the next one. So parse Boolean, looking at the documentation, says that it's going to return true if the string it actually has the word true in it. Otherwise, anything else means it'll be false. So that's pretty cool. Helpful there. But now let's do the end. So else if fields sub 0 dot equals int, is that what we printed out? It is int and double. So if it's an int, now we're going to say var int value equals new int value. And we will say int value dot set name fields sub 1, and int value dot set value is going to be integer dot parse int field sub 2, and then data dot add int value. But now, because this could potentially throw a number format exception, and if we hover over this, we'll see here the documentation right up there says it'll throw number format exception. And so we need to handle that, and we need to decide what we want to do with it. So this is where you say, what's the right way to handle this? And the right way to handle this in this case isn't to exit our program, but it might be to throw an IO exception that says invalid file format. And then we can give it the line number, just like we've done up here. So that's what we're actually going to do. So we're going to wrap this if-else. I can't break the if-else-if ladder to be able to try just on the last two. So we're just going to do a try here and make sure our indentation is consistent, and we're going to catch a number format exception. And we're going to then throw a new IO exception. And we're going to give it a message, which is invalid file format online, and give it our line number. And then we're also going to include the exception, which is this constructor of the IO exception lets us pass the root cause. So the root cause would actually be the number format exception. We're going to wrap it in an IO exception with a descriptive message on it, and then throw it up out of this method so that our demo will catch it right here and print it out in that case. All right, one more thing to go, and then we're going to be done. Else if fields sub-zero dot equals double. Some newer versions of Java actually give us a switch statement that would support the strings. And we can actually, I think we can do that in the version I've got here. I'm going to leave it as an if-else-if ladder because it flows a little bit better, but we could actually use the switch statement. And maybe at the end of this, after we see the program work, I'll convert it for you so you can see it. So we're going to say var double value equals new double value. And then we're going to say double value dot name dot set name fields sub one, and double value dot set value. We're going to do double dot parse double. So we're the double class, remember that's the capital double is a wrapper around a primitive double, and it provides helpful methods like parsing. That's what we're calling is this double wrapper class has a parser method built into it. And then we're going to say fields sub 2. And we need to add it to our list. So data.add double value. We've added our data until we get to the end of the file, and we should be good to go. So let's come back to our demo, and let's see how far we get. Look at that. Look at that. Here's our original values, which we already knew worked. Here's our reloaded values. And we know by the way we wrote the code that this has actually worked. So I think that's the first time it's ever worked on the first try, honestly. Pretty darn cool there, though. So let's go take a look at our values file. And there it is again. And voila. So of course, I will post this code to the code samples for week 13. And you'll be able to see it and analyze it there. And then at this point, you can stop watching. It's one of my shortest videos yet, isn't it? You'd think I'd get faster at this. But now I'm going to convert this to a switch statement and show you what it'll look like. It's not going to make the code really any simpler because I still have to do these 4 lines for every case, but maybe it might declutter the lines a little bit. So we're going to, let's do this and say switch on field sub-0, and I can say case string, and then we'll just come up here and grab all of this and paste it in, and we'll put our break at the end. Well, that was easy. Yeah, let's do it this way. This is a lot better. So let's just bring all this in and do case. It used to be in Java, you couldn't use strings in your case statement. and we typically will indent under our case statement. So case int and case double and that should do it. We still have to have the try catch around it because these two, the int and the double, could throw a number format exception. And let's just double check and rerun our demo and make sure that our switch statement works. I'm sure that it does. There it goes. Okay, so we've cleaned up the code there. That's pretty cool. Now I'm going to run through this one time in the debugger. If you already are an expert in using the debugger, fine. You don't have to stick around for this, but you may want to just to one more practice of learning how to use debugger. If you have gone all semester and said I really should learn how to use a debugger, you're going to kick yourself for not taking the time to do that, because as you get into more programming classes, that debugger is going to be your best friend, and this was the time that you had to get to know it so that you could be productive with it. Okay, so I'm going to, we really only care about our store data and our load data methods, so I'm not going to step through everything else in the demo file. So I'm just going to put a breakpoint right here and a breakpoint right here. Now I'm in Visual Studio Code this week. The debugger does all the same things that IntelliJ's debugger does, except it just puts things in different places on the screen. So I'll try to highlight that and point you, reference you to where you want to see it. But if we come back to our demo and we click the debug, then our program's going to run, and you can see here we've printed out our original values, and now we're going to write out our file. And the print writer method, it will overwrite whatever file we give it. If that file happens to exist, it's going to just slap the new file over the top of it. So that's something to be aware of. In our case, it doesn't matter. That's what we want. We want it to write the whole file again, so we're just going to do that. So now we're going to step over. So we've got our writer, and our variables show up over here. We've got this writer. I've also got a debug console that will allow me to do some extra stuff. I don't think I'm going to need that this week, but it just lets you peek into the debugger's internals and see what things look like in there. So we've printed out this comment line to the file, and now we're going to start our for each loop on value. So now you'll see I've got this value, and it's a string value object, and it's got a name and it's got this value, and I can actually expand it here and see the name and the value. And so it is an instance of a string value. We see that here by the debugger giving us the type. And you'll notice here, let's take a look when we did this cast, right? So I've got this value object that the compiler says, oh, it's a value. I don't know anything about a getValue method, but I know about a getName because that's on the value class. To the computer, it makes no difference other than it makes no difference, right? So our value here is our string value at 38, and once we've cast it to a string value, it's still the same pointer in memory. So all the casting does is it tells the compiler to interpret that as a string value object rather than a plain value object. And that way the compiler knows, oh, you've got this extra method here that you can use. But to the computer itself, it's not going to matter. It's still the same pointer in memory, and it's going to try to do whatever the compiler has coded it to do. All right, so we know that was a string, so we write out the string, and now we go back to the top of the loop. And the next value coming in is our Boolean value, and we can see that there, that it's Boolean and a true. And so now we just write that out, and our next value is going to be our int value, I believe. We'll see our int, and we hop down and we write out our int. And our final one is going to be our double value. And we're going to write it out and let's see what the double looks like. So that's the value there, and our double gets written out. And voila, we're done. We're at the bottom of the try, so our file gets closed. And we can actually come over here now and look at our values, and there's our values, of course. And now we're back out in our demo, and we didn't get an exception. And so therefore, everything's happy. And I'm going to hit the continue button, and now we're in our load data. So now we're going to walk through, and we're going to watch us build our file. So what we're going to look for here is we've got our line number coming up. We've got our input scanner. We've got our line number there, and we're going to have a variable called line. And I'm actually going to put these in the watch window so that they don't hop around as we go through the different scopes within our loop. So I'm going to say our line number we want to watch, and our line value. So that's the actual value that we've read in. Can't evaluate because we haven't executed this line of code yet. As soon as we do, then the watch window will figure it out and start showing values. And then I want to watch my my data list, which data already exists up here, but I'm going to stick it down here in my watch window because it's a little more convenient. All right, so watch. Now I've got my line. It's my comment line. My line number I increment, so that's the line 1 of the file. And then I check here. I trim it and I check to see if it starts with my comment character, and it does. So we're going to skip the rest of the loop, go back to the top, and check and see if we have another line to read. We do have another line to read. So this is our string value. Our line number goes to 2. It doesn't start with a comment, so it's a data record. And now I'm going to get my fields. So let's actually watch our fields here too. So there's fields. I've got string, value 1, and the string value. I have 3 values in it, so we're going to just continue forward. And now I'm going to switch on field sub 0, which is string, and so we're going to go execute our string code. And then we move forward. Next up, now we've read our Boolean value. So you guys see where this is going, right? We're just chugging right along. Everything's happy. And as we do this now, you are now all experts. You've seen how to write a file input and output routine for any custom format of file that you want to write. Now, one thing that we don't have time to cover this semester, but they will cover in future semesters in other courses, is how we actually use files in our day and age. I may have mentioned in the office hours this week that we almost always just use either JSON or XML for our file formats anymore. Databases like Oracle and MySQL and Postgres, they have binary file formats, and other applications will have binary file formats because that's what's most efficient for them. But for our purposes, we're just sending text across the network in an HTTP request most of the time. And so a text format works great. And JSON and XML are both structured enough that we don't have to come up with our own format. And that makes it interoperable, that I could write my data in JSON format and somebody else could easily parse it at the same time. If I wrote out my custom format, I would have to publish my file format to them, and they'd have to write a custom reader to parse it like we've done down here, to parse it all and put it back into objects. So JSON and XML, you still have to do the same thing, but they've got generic tools that do the writing and the parsing for us. And we just get a list of our own objects back out of it. So now that's really it. That's all that I have to demonstrate to you. You'll see here we've got the success. In your projects, this is all we're asking, is that you have an array list of your base class. You're going to put your child classes in it. You're going to write them out to a text file, and you're going to read them back in. Or if you've chosen to do something else for your file reading and writing, you can do that. You just have to be able to read and write the file data and present it in your program. All right, good luck to you. It's been a great semester. I wish you all the luck.